Good morning, integrated topic students. Ms. Connor here for today's lesson, which is April the 28th, and also for April the 29th, which is a Friday, last Friday of the month. Today, we're going to need some paper for some notes. Also, take out your factoring packet from last class. Unfortunately, I will not be able to put that onto the website, but what it was just a lesson for people to fill in spots dealing with what two numbers multiplied together will give me one number, and those same two numbers added together will give me another number. So really just try to keep people on track with the multiplication and also the addition of numbers. And again, we're going to have a pencil and a calculator. So what they did last time, there was like a 4-page packet, and there was certain groups of students that just had to do one of the 4 pages. So if you did, let's say, the first page of the packet, now I want you to do is a jigsaw. So I want you to go and find other people that did the second page, that did the third page, and the fourth page, and then you share out what you got for your answers for the first page of that packet. So once everybody got their answers through the jigsaw, I showed my answers just to make sure that everyone had the correct solutions for their packet answers. So for today's lesson, the title is Factoring Trinomials. And just as a reminder, when you're doing factoring, it's just basically distribution in reverse. So if you haven't noticed, every time we've done factoring, it involved parentheses. And was just a visual example. So we had x plus 2 times x plus 3. And if we were to solve this, that means we wanted to do the distribution of our x to everything inside the parenthesis, which gave me x squared plus 3x. And then we would have to distribute the positive 2 to everything inside the parenthesis, which gave me plus 2x plus 6. And if you notice, right here in the center, we had our like terms, so we combined those, which gave me a 5x. And then we'll just bring down my x squared, and we bring down my plus 6. And this was how we would do the distributive property. And you notice, originally we started out with 2 binomials, and once we did the distribution, we came up with 1 trinomial. So what we're going to do this time is we're going to start out with our trinomial, and we're going to figure out what the original 2 binomials are. So looking at this, just thinking about all the things that we dealt with so far with factoring, do we have a GCF? In this case, my answer will be the only GCF we have is 1. Because remember, there's a 1 understood to be in front, and 1, 5, and 6, the only number they have in common is 1. And we don't have any x's in common because with my 6, there's no x there. So since my GCF is 1, I also got to learn that my leading coefficient is also 1. So if you remember, if I put this in standard form means I have ax squared plus bx plus c. That's an equation in standard form. And a, b, and c are representing numbers. So what I'm looking at is when my a, or my leading coefficient, when that leading coefficient is 1. And we're going to do some solving. So the best way for me to do this is to show by examples. So let's actually do an example. So we have x squared minus 8x plus 12. So right here, my greatest common factor for this expression is 1. My leading coefficient is 1. So when I have that situation, I automatically go to 2 parentheses. Because like we saw in the beginning, if I started out with 2 binomials multiplied together through distribution will give me a trinomial. So now we're going to solve factoring in reverse. So I have my two parentheses. Now I'm looking at my first term. Whatever my variable is, I'm going to split those two variables in each of the parentheses. So that means I'm going to put an x in one of the parentheses and an x in the other parenthesis. So once I split my variables, I'm going to go to this last term. And this is where that packet's really going to come into play. So this last term, if you notice in the packet, we had three columns. The first column dealt with the numbers that we were going to find that represents the product and the solution. And the middle column dealt with numbers that we add together. And the last column dealt with numbers that we're going to multiply together. So this is what we're doing. I want to know what two numbers multiplied together will give me this last term. So we can do 6 times 2, 4 times 3, 1 times 12, and then also the negatives of those. Okay, so these are all the products of that positive 12. So we remember we can do the negatives because negative times negative is positive. So now here's the next part. We want to know which one of these products add together will give me my middle term of a -8. Right now, the best one will be right here, -6 times -2. Because a -6 times -2 gives me a positive 12, and a -6 plus a -2 gives me a -8. So that will be my solution, or that would satisfy those two terms. So inside the parenthesis here, I'm going to put -6 because I have a -6 over there. And I'm going to put in my other parenthesis a -2. This right here is the factoring of that trinomial x squared minus 8x plus 12. If I wanted to check this, all I have to do is the distributive property. So if I want to check it, which I'm going to put in red, I would have to take this x and distribute to everything inside the parenthesis, which would give me x squared minus 2x. And then I would take my -6 and I would distribute to everything inside the other parenthesis, which will give me a -6x plus 12. And then right here, I have like terms, right? So my like terms will give me a -8x. And then everything else is just coming on down. So here's my x squared, and here's my plus 12. If you notice, this right here is the same trinomial that we originally have. Can you see it? Okay. So you can do the checking to make sure that you have the right signs, to make sure that you have the right positions. If you said your solution was, let me put it up here, was x minus 2, ooh, that's supposed to be an x, minus 6, that's correct as well. Because remember, when you're multiplying, you can change positions as long as that 2 and that 6 are in the correct indication, okay? They both are negative, okay? Let's try another one. So we have k squared plus 20k plus 36. So my greatest common factor is 1. My leading coefficient is 1. So automatically, I should be thinking I want to split my k's up into two parentheses. Now, I'm going to this last term right here, this 36. What two numbers multiplied together will give me 36? So you can say 6 and 6, you can say 18 and 2, you can say 4 and 9, you can say 1 and 36. If you want, you can also use the negatives of those. So now I want to ask myself the question, what which one of these two products added together will give me a positive 20. So hopefully you say 18 and 2, because 18 times 2 is 36, and 18 plus 2 is 20. So notice those numbers are positive. So I'm going to put a plus 18 here and a plus 2 there. This right here is your factoring of the trinomial. Okay? Example number 3. What's different? We got an equal sign and we have two minus signs, but we're going to do the same thing. So what we're really doing with this problem is taking what we just learned about factoring trinomials and we're mixing it up with Okay, so we got Ninth Grade Academy with their meeting. Good job. So, since it's equal to 0 and it's factoring, okay, that means we're going to do what we did last class when it came with solving. So every time you see an equal sign, you are solving. So, again, d squared minus 5d minus 24, the greatest common factor is 1. My leading coefficient, which is in front of that d squared, is 1. So we're going right into my two parentheses. I'm going to bring down my equals 0, and I'm going to split my d's up. So now, what two numbers multiplied together will give me a negative 24, and added together will give me a negative 5? So we really got to think about our multiplication table. So you always go to this last term once you split your variables up. So for 24, you can say, 12 and 2, and one of them has to be negative, so you can say a negative 2, or you can say a negative 12. You can go 8 and 3. Let's make the 3 negative there, and then we'll make the 8 negative here. What else can we say? 6 and 4. So one of them has to be negative. And there's probably, we could do 1 and 24, but right now, I don't think it's necessary. So now let's look at our choices. Which of those products added together will give you this middle term of negative 5? Hopefully, you said negative 8 and 3. So since my 8's negative, I'm going to minus 8. And my 3 is positive, so it'll be a plus 3. Okay? So now, normally we would be done. But in this case, we have it equal to 0. So just like solving the equations like we did last time, that means we have d minus 8 is going to set equal to 0. And then we have d plus 3 is going to be set equal to 0. So once we set those two factors to 0, we got to solve. So here, I'm just going to add 8. I don't know why I put parentheses around there, but sure. We're going to add 8. So now d is going to equal positive 8. That's one of them. And then for this one, we're going to subtract 3 on both sides. So we have d equals negative 3. So my solutions for this equation is 8 and negative 3, meaning I can plug an 8 in for d, and it'll make that equation equal to 0. And I can plug a negative 3 in for d to make that equation equal to 0. Okay? For example, number 4. So again, we have another equal sign, so that means we're solving. But just like solving an equation, our equations must equal 0. So what must I do? Hopefully you said I should be adding this 45 to both sides of the equal sign. So now here's a question for you. Can I combine that 45 with anything on the left-hand side of that equal sign? I cannot, because that 45 does not have an A, so I don't have like terms here. So all I'm basically doing is just rewriting my equation, whoops, and setting it equal to 0. So now we're taking what we just learned. My greatest common factor, again, is 1. My leading coefficient is 1. So I'm going right into my parentheses, and that's going to be equal to 0. And I'm splitting up my variable, which is A. So with the 45, what two numbers multiplied together will give me 45, and added together will give me 14? Hopefully you said 9 and 5, and they're both positive, because 9 times 5 will give me 45, and 9 plus 5 will give me 14. So now that we're dealing with equals 0, that means we need to set these factors equal to 0. So for this equation, 8 plus 9 equals 0, that means A is equal to negative 9. And where the negative 9 came from, that you're subtracting 9 from both sides. And then over here, A is going to equal to negative 5, because I'm subtracting 5 from both sides. So my solution here is negative 9 and negative 5. Okay? So far, if we may recap, I know I'm going to be solving when I see equal signs. If I don't have equal signs in my original expression, that means I'm not solving. I'm just looking for two parentheses with my factors in it. So for example 5, and this is my last example that I did in class. I have x squared plus 6xy minus 16y squared. I don't have equal signs, so that means I am not solving, but I am factoring. So my GCF, again, is 1. And my leading coefficient, so I have x squared, but I'll also have a y squared. But I can still factor this out. So if I look at those x's, I know I'll have an x in the front of each of the parentheses, but I have a y squared back there. So it's kind of tough for me to say, oh, my leading coefficient, because I have 2 of the same degrees. But with that 16y squared, I can split those y's up, but I'm going to put those y's towards the back, because it is in the back end of my expression. So now I'm still doing the same thought process. What two numbers multiplied together will give me a negative 16 and added together to give me a positive 6? So for negative 16, you can say negative 4 times 4. You can say negative 8 times 2, or you can switch it up with 8 times negative 2. Again, you can have 1 in negative 16 or negative 1 in positive 16. Okay? So which one of those products added together will give me a positive 6? Hopefully, you picked this one. That means I have a plus 8 and a minus 2. This is the factoring of our original trinomial. And you're probably saying, well, Ms. Conner, we got x and y with that 6. Like, how is that possible? Let's try with the distribution. If you want, we can check it. Because when I distribute, remember, we're doing multiplication. So when I distribute this x, I'll have x squared minus 2xy. Remember, we're multiplying. So when we're multiplying, we're putting those products together. Now I'm going to distribute the 8y, which gives me plus 8xy. Remember, there's no order when it comes to the multiplication, minus 16y squared. Right here in the center are my like terms. So negative 2 plus 8, that would give me my 6. I'll do it in red. 6xy. And then everything else is coming on down because they're not like terms, so I cannot combine them. Isn't that the same as my original expression? Okay? So it looks funky, but if the hardest part I feel is to figure out what two numbers multiplied together will give you your last term, and those same numbers added together to give you your middle term. So the reason why I have you guys do the packet is you can use that packet to use as a reference. Okay, that's why I did not collect it. Yes, you guys worked really hard on it, but I don't want to collect it because it's going to be something that's useful to you. So after we did those examples, I gave them these 3 to try. And if you want, you can pause it, give these problems a try, and then check your answers. So if you paused, very good. Let's check your answers. So for the first one, we just have an expression. So that means there's no equals anything. My leading coefficient is 1 because I have the highest degree of 2. So that means I'm splitting my x's. And then I'm thinking, what two numbers multiplied together will give me positive 24 and added together to give me 10? So in this case, I have a plus 6 and a plus 4 because 6 times 4 is 24 and 6 plus 4 is 10. That's my answer for number 1. For number 2, we have b squared plus 4b minus 45. My leading coefficient is 1, so I can go ahead and split my variables of b. What two numbers multiplied together will give me a negative 45 and added together to give me a positive 4? So we know that 9 and 5 will work, but which one's going to be negative? Hopefully you said the 9's going to be positive and the 5's going to be negative, because 9 times negative 5 is a negative 45, and 9 plus negative 5 is a positive 4. So b plus 9 and b minus 5 is my factors. And lastly, so now we have an equals 0. So that means we're going to solve after we factor. So if I have my leading coefficient of 1, that means I'm splitting up my p's. And I'm thinking, what two numbers multiplied together will give me 28? So we can use what? 7 and 4. Would that give me 16? We can use 14 and 2. Would that give me 16? 14 and 2 it is. Are they both positive? Yes, they are. Because 14 times 2 will give me 28. And 14 plus 2 will give me my middle term of 16p. So now that it's equal to 0, we need to set each of those factors equal to 0. So let's go ahead and solve. So that means we have to subtract 14 on both sides here, which gives me p equals negative 14. So that's one of my solutions. And then over here, we're going to subtract 2 on both sides. So I have p equals negative 2. So this is telling me that negative 14 and negative 2 are the two values to make our original equation equal to 0. Okay? So after we did all that, copied down her homework. I know it seems like a quick class, but it went kind of bell to bell. So we have these 4 homework assignments. Had time to do, some people had time to do it in class, some people didn't, and they just went ahead and turned that in. Okay? So, looking over the schedules, fourth quarter is going to go by real quick. Okay? So this was the lesson for April the 28th and the 29th, which is the last days of April. Then we have one full week. Might have a little quiz next week just to reinforce what we're learning, just to make sure we're on track. And the following week, we're having another summative assessment. That's going to be like the last assessment for this quarter. Because the following week, which will be May the 16th, that's HSA week. I may only see classes once or maybe twice that week. Because what's going to happen, we're going to have HSAs in the morning. Then people come in during Wildcat hour. That's when the rest of the school will come in if they don't have to take an HSA during Wildcat hour. And then we're only going to see 2 classes after that. So it could be 1A, 2A. It could be 3B, 4B. Okay? So it all depends. That will be Monday through Thursday, and Friday is a makeup day, but that's going to be a full day. So that schedule is going to be kind of loopy. The following week, starting on the 24th, May 24th, I'm going to actually start doing my seniors' presentations. So while the underclassmen, they may be working on their projects for their final exam, and I'm going to actually be taking on my seniors and working with them with their presentations. Okay? So that's going to be the week of the 23rd, because the seniors' last day is the 27th. May 30th is a holiday. It's going to be Memorial Day, so we don't have school. And I think June 1st is graduation, so there's not going to be school for underclassmen on that day. And trust me, after that, we're going to we have what, 2, maybe 3 classes, and then it's time for finals. So it's going to be real quick, and we're going to try to do a lot of the stuff for the finals in class. We have factoring left, factoring when our leading coefficient is not 1. And then we're going to do transformations of quadratics. And after that, it's time for finals. So it's going to be quick. Not too many assessments, if anything, just a couple quizzes here and there. But when it comes to summative assessments, we're only going to have like 1 left. All right? So any questions or any concerns, please don't hesitate to come see me during Wildcat Hour. I'll be here Tuesday, Wednesday, Thursday, first lunch. Schedule has not changed for the past 2 years. Ms. Cabanel will be here on Monday, first lunch, and Friday on first lunch. Okay? So I will be seeing you guys. Take care.